Hello, everyone. We're Group 34 from UCSD Bioengineering Senior Design. Our project, in collaboration with the She Lab at UCSD, uses Raman spectroscopy to compare the chemical quality of antibiotics made in the United States versus abroad. And here we're addressing a major concern as over half of Americans worry about accessing reliable medications. So here's the list of antibiotics that we use to compare domestically versus internationally. And as you can see, when we normalize these per 100 grams, we found that the domestic prices are far more expensive versus the Chinese versions. And so, to address this disparity scientifically, we're using a non-destructive light-based technique called Raman spectroscopy to detect these structural differences. And specifically, we focus on Stokes Raman scattering, where laser light loses energy as it interacts with molecular bonds, and that energy shift reveals a drug's unique spectral fingerprint, helping us spot inconsistencies between variants. And so, with this, we're hoping to build a searchable antibiotic spectrum database for low cost rapid screening. With this tool, we aim to increase transparency and make medication safer and more affordable worldwide.
Here we have our Raman spectroscopy results. By comparing the international spectra with the domestic reference, we could observe missing peaks that indicate the absence of certain important chemical structures, or additional peaks that indicate impurities in the international sample. For example, for fosfomycin and colistin, we observe mostly similar peaks and a few extra peaks in the international sample. This means that the international sample does contain the genial structure, but has some minor impurities. However, for azithromycin and ciprofloxacin, we observed that the spectra for the domestic and international samples are very different, and a lot of peaks are missing. This could mean that the international sample is likely not effective, and this innovation can make the world a better place by providing a rapid and reliable tool for access to the quality of drugs from different sources, especially in low-resource countries that rely heavily on international drug imports. So Raman spectroscopy is a better tools and existing methods because it's non-destructive and it requires minimal sample preparation.
So next part of the project is we want to validate our database with minimum inhibitor concentration assay. And by comparing the result with our Raman database prediction, we found that minor quality issues is linked with minor efficacy shift, and severe quality issues is linked with severe efficacy shift. So this result shows that our database prediction can align perfectly with real-world biological effectiveness.
Okay, so now I want to show a brief demo of our reference database. The function we want to advertise the most is the upload function, which you can upload your own data and then achieve drug screening. For example, we want to check for fosfomycin. So you click for fosfomycin and the reference data will show here automatically. And then you upload your own version. In this case, I will upload the expired version of the fosfomycin. And then you simply upload and plot. Then the website will automatically process your raw data, and then you are able to by vertically compare the peak position and horizontally compare the peak intensity. You are able to have an initial guess of your drug quality and then make a next step decision of if you're going to the further step for your experiment or you go back to the beginning and pick another drug. And this functionality basically made the research into a better place because it is much convenient, time-saving, accurate, and efficient than human intervention during the drug analysis. This is because everything is an automatic and standardized process, so people aren't able to make any mistakes during the process, and everything is just there ready for you to watch. And the impact we have for this project, including make this website more prevalent for Raman-based imaging researchers, especially in the drug screening field. And also we want to bring Raman imaging to a more popular place. For drug screening purpose, currently Raman imaging is still a relatively new technology that people aren't that kind of familiar with. But I believe because drug quality is always a very concerning issue for people, so if we can advertise Raman in this functionality, then this technology can be seen by more people and make it benefit more scientists, people, and drug manufacturer industries.